Welcome to the Biowalk for Biofuels project. I'm Silvano Simoni, the scientific coordinator of the project. I've been coordinating the project with 10 international partners for the last 5 years. We have the same goal, which is to demonstrate that the problem can become a resource, and we did that through scientific, multidisciplinary approach. The issues we had to tackle were, first, eutrophication, second, tons of greenhouse gases like CO2, third, biowaste, which is quite difficult to manage. What we have been able to produce, and this is the big innovation, is renewable energy and biological fertilizers.
The Biowalk for Biofuels is a project financed by the European Commission under the European Research called 7th Framework Programme for the theme Energy 2009. The aim of the project is the construction of a demonstration plant for the production of renewable energy using algal biomass. The project required an investment of 3.9 million euros, of which 2.9 million paid directly by the European Commission, and the residual part was funded by the project partners. The project will run for 4 years and will be ended in 2014.
The coordination of the project is carried out by the Department of Chemical Engineering, Materials and Environment, DICMA, of the University of Rome La Sapienza, and the partnership is formed by 10 subjects:
Italian, Danish, Indian, Latvian, Jordanian and Spanish. The infrastructures are located in the Bay of Augusta. The plant is built in sea in a watery mirror given in concession by the maritime state property for all the duration of the project, as well as the ground, where the equipment are positioned for the production of biogas. All inputs will be introduced in 4 PVC open ponds, where the selected macroalgae will be cultivated or in a homogenization tank. This allows the control of the cultivation parameters, unlike the open sea. In fact, jet air connected with the ponds will provide water and CO2 to the algae broth, guaranteeing biomass mixing.
The Biowalk for Biofuels project. Biomethane from algae as a vehicle fuel. Process description. The B4B process uses several units to produce renewable energy from algae. Let's follow the main points of the process. The B4B promotes a new kind of algae cultivation using 4 PVC open ponds, in total 3,600 square meters, in which a macroalgae selected for the project was cultivated, Ulva lactuca. This artificial environment allows the control of the cultivation parameters, unlike what happens in the open sea. The ponds are provided with seawater and CO2 in order to guarantee both biomass mixing and CO2 fertilization. At the same time, eutrophicational agents coming from the biodigesters, a unit of the process, was introduced after undergoing an appropriate treatment, achieving a closed cycle. The management of the cultivation assures a strict control of several parameters: pH, nitrogen compounds, phosphates, etc., avoiding uncontrolled water exchange with the open sea. Controlled open ponds. We have designed a remote-controlled system that, thanks to the electronic sensors, remote-controlled valves and remote-controlled pumps, permitted to all the Biowalk for Biofuels partners a total remote control of the entire demonstration plant. Thanks to this advanced package of software and tools, we was able to assure a remote management and supervision at a very high level of safety and reliability. The construction of the open ponds plans to achieve 2 important targets. First of all, algae growth is related to the climatic conditions of the place where the cultivation is established. Second, the system allows to optimize costs in order to produce an amount of biogas 20 cubic meters per hour, sufficient to power the cogenerator and ensure a sustainable energetic process, an input of 400 kilograms wet of algal biomass in the B4B digester, and 3,600 square meters of open pound surface are necessary. Protoplasts. The use of protoplasts as feedstock for cultivation using a protoplast-based seedling production facility made it easier generation of required seed stock for feeding of floating tanks regularly. A protoplast incubator was to be used to produce protoplasts to feed the open ponds with a new little algae. This type of cultivation in an incubator results in an increased productivity and a higher biomass yield. Protoplasts are living plant or algae cells without cell walls, which offer a unique uniform single-cell system that facilitates several aspects of the modern biotechnology. The incubator aims at demonstration of the use of protoplasts as an alternate source of spores for cultivation of green seaweed ulva. This facility basically facilitates continuous production of seeding biomass required for a large-scale cultivation. Harvesting system. The harvesting system represents the link between the open ponds and the subsequent anaerobic digestion process. For this task, we used an automated drone planned and engineered for the B4B purposes that could harvest directly in the open pond the daily amount of algae. The drone took the algae amount close to the collection point, where a pump sent all harvested algae to the preparation section. All the harvesting paths and the return paths to the base for battery charging are guaranteed thanks to precise GPS system mounted on board that exchange data with the central server. All the technology for the construction of the drone was developed by the partners involved in the design and management of the system of harvesting. The automation system is managed by a software developed in the programming language LabVIEW, totally open for the necessary change during the search. Preparation tank. The preparation of biomass mix, which is the input of hydrolysis and methanization, takes place in a pre-treatment phase. In this step, there are many sensors monitoring the level of input biomass, giving the start-stop input to a grinder pump and a signal to open-close automated valves. The preparation tank, which volume is 12 cubic meters, receives all the biomasses used in the process, and thanks to the grinder pump and cleaned water, permits to better control density of biomasses in the input of the hydrolysis tanks. Big bag for macroalgae biomass. The big bag permits to separate for each batch input 500 liters of salt water from wet algae without using energy. From the big bag come macroalgae biomass harvested from open ponds. The big bag castle is placed over the preparation tank. Thanks to the software developed for this process, it is possible to automatically control the charging phase of the algae and their separation from the salt water and its recirculation to the open ponds. Grinder pump, screw pump, draft pump. When macroalgae and the other biomasses for the mix come into the preparation tank, the grinder pump, which 3 per 1 second, starts to shake the biomasses and get them ready for the homogenization phase. The movement of the biomass to avoid areas of sedimentation is assured by this pump, which thanks to a valve can activate the recirculation system into the preparation tank. Homogenization tank. The homogenization tank is built of inox steel to prevent the corrosion of the salt water and has a 30 cubic meters volume. This tank allows us to have always at our disposal an amount of well-mixed biomass to be used in the digester unit. Before entering the homogenization tank, the biomass is pumped in a hydrocyclone for the removal of sand. In the output of homogenization tank, there is a pump operated through an ABB inverter that allows the variability of the flow. Methanation. Two-stage reaction system has been proposed as a solution to improve the overall process efficiency in terms of biodegradation rate yields and overall energy productivity. In fact, splitting hydrolysis, acidogenesis, and methanogenesis is enhanced the overall reaction rate, maximized biogas yields, and made the process easier to control, both in mesophilic and thermophilic conditions. Moreover, enriching different microorganisms in each anaerobic digester, the two-stage AD should extend the possibility of processing different biomass species, enhance substrate conversion, improve the chemical oxygen demand reduction (COD), and upgrade percent energy recovery. The first reaction step takes place in two CSTR reactors in series which operate at high temperatures, approximately 70 degrees. This temperature is kept constant through a heat exchanger located inside the reactor. In the hydrolysis reactors, mixing takes place thanks to a system of gas lifters that consist of a gas blower. The conversion of biomass into biogas occurs inside the methanation reactor. The innovative aspects of this reactor are B4B rotor and the mixing system. The drum rotates using the biogas produced by the anaerobic digestion that is blown on the bottom of the reactor close to the sidewall of the drum. In this way, the biogas, which tends to rise, applies a moment to the rotor able to rotate it. The advantages of this system are efficient handling of solids suspended in a wide range of rotational speed, lighter and less expensive structure than reactors operated mechanically. It acts like a mixed system, biofilm plus suspended biomass. It requires very little maintenance. It can work with very high organic loads using a total volume smaller than the one required in the conventional reactors. Cleaning and safety flare. The biogas produced in the methanation reactor contain, in addition to methane and carbon dioxide, water vapor, ammonia, and H2S. The concentration of these gases are monitored by a gas analyzer connected to the input and the output of the cleaning section of the biogas. The compounds that must be removed in order to make the biogas can be used are water vapor and H2S. Then the process of purification, gas cleaning, of biogas provides a dehumidification by chiller and a desulfurization by adsorption on activated carbon. The condensation is an important physical method for removing gas or vapors pollutants. The process consists in cooling the stream in order to reduce the saturation pressure and consequently trigger the condensation of the species. In order to maintain the values of H2S in the biogas below the limits prescribed by law, the biogas is sent to an absorber with activated carbon. The adsorption consists in transferring a chemical element from the gaseous phase to a solid phase. Safety flare is used in biomass plants to ensure a controlled combustion of the excess gas produced by the anaerobic digestion section. The apparatus is composed of several elements, but the most important are two. Ignition electrode, generating high-voltage electrical discharge during startup. UV sensor, continuous detection of the presence of the flame. Electricity production. A cogenerator 45 kilowatts produces electrical energy using as fuel the biogas produced by the methanization process. The CHP unit installed in the B4B system is an Iveco Tandem T45. The cogenerator heat recovery from the flue gases and from the cooling circuit of the engine is useful for heating the digestion process. At the same time, an electrical output equal to half the thermal energy generated is produced. In the hydraulic circuit of motor, cooling water outlet temperature is 80–85 degrees. Water circuit transfers the accumulated heat to the hydrolysis tank. It was necessary to install a heat sink to ensure the cooling of the liquid in case of insufficient heat exchange for the hydrolysis in order to have lower return temperature of the liquid to 73 degrees. Upgrading. Several upgrading processes have been analyzed to separate the biogas impurities and CO2 from CH4. In this way, compressed biomethane gas for automotive purposes or natural gas grades injection can be produced. The characteristic of the upgrading system analyzed has the ability of equalize the composition of the biomethane, treating biogas produced by very different biowashes.
To produce a cost-efficient, low-energy intensive, purified biogas, biomethane, to reduce negative environmental impact from industrial greenhouse gases and from biowaste is now possible, thanks to the Biowalk for the Fuel project and to the work done by the international partnership. We are looking forward to future developments and we are ready for new challenges in other world sites.